last class we have stopped here. What we are going to talk about, we will continue talking about the subnetting. As you know, last class we talked about the subnetting, and we have explained how we can divide our subnets into a number of subnets or subnets, let me say, by using what? Equally sized prefix, equally sized subnets, which means if we subnet /16, for example, to 24, we will create many subnets. All of them have the same number of hosts, per subnet. How we know how many hosts? According to the bits of the host portion, 2 to the power, the number of bits, minus 2. Now, sometimes in the same network, we'll have a different IPv4 addresses. We have internal addresses or intranet addresses, like the one you are seeing here. So we have intranet network, LAN network. So in the intranet, the company, for this example, will use what? A private IPv4 addresses. And we do not have any issue with this. Now, what about the other zone, the DMZ? DMZ actually stands for demilitarized zone. Usually, it's a part of the company network. It will contain resources like the services, the servers you are seeing here in this example. And these resources should be available and accessed through the internet network. So, such as the web server, for example. So what we are talking about here, it's a public IP address, not a private IP address. So DMZ's companies is a company's internet-facing servers, devices in the DMZ using a public IPv4 addresses, public. So in this company, we can use the prefix 8, we can use 16, or we can use 24 subnets for our network boundary. Now, keep in your mind that these devices, which called DMZ devices, would have to be configured with a public IPv4 address, not a private. So this is the problem now. What's the problem? For any organization, when we're talking about the public IPv4 address, we know we have a limited number of public IPv4 addresses. So the organization or the company must maximize its own limited IPv4 addresses, which means it requires the network administrator to subnet their public addresses space into subnets with different subnet masks. What does that mean? The subnets should not be equally or having the same subnet mask. We can divide the DMZ zone or subnet the DMZ zone by using /25 and 26 and 27. So we'll have a variable subnet length masking, VLSM. So the subnets will not be equally using the same subnet mask, so they will not have the same number of hosts. Let us take an example. Now, why we are doing this? Why we will subnet our subnet by using a different subnet mask? Simply, we need to avoid having unused public IPv4 addresses. We do not want to have IPs, and those IPs are not used at all. So we are wasting our limited public IPv4. So we have two considerations when we plan to the subnets. What we need to take in our consideration, the number of hosts, addresses required on each network, and the number of what individual subnets needed. So how many subnets we need to subnet our network, how many hosts per subnet. It will not be subnets by using the same prefix, as you will see in the coming parts. So as we have discussed before, subnets are created by borrowing a bits from the host portion according to this table. So if you borrow 1 bit, we have 2 subnets, 2 to the power 1, 2. Now the total number of available usable hosts, 2 to the power 7 minus 2. 2 to the power 7, actually I have 7 bits here. 128 minus 2, 126. Why minus 2? First address always for the network address, the last one for the broadcast. Between the usable IP addresses can be assigned to any host. So let us take an example. Suppose in an organization we have the following address space: 172.16.0.0.0/22. What does /22 means? Means we have a 22 ones for the subnets, so the network portion will have a 22 bits and 10 bits for the host bits. So how many available hosts address we have? 2 to the power 10 equal 1024 minus 2, 1022 usable now host address. Now, so let us assume in this network 172.16.0.0/22, it's a part of the IPv4 private address space. Now, what we need to do now, this one, let us consider this address is a public, the public IPv4 address for that organization or company. Now, we cannot write the actual public address, so we use this private address, for example. Now, how many subnets we have in the organization? We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Now, for the first one, we need 40 public IPv4 address. The number of addresses needed. For the second one, we need 25. Next one, we need 30 public IPv4 address. The next one, 10. And the last one, 15 public IPv4 addresses. So on this network, we have 10 hosts bit, as we have said. So we have 22 usable host address can be used in this network. Now, my question is the following. Now, how many subnets needed here? Actually, we do not need 5, we need 10. Why 10? We have 5 sites and we have 5 internet connections. So it means what? The organization will need 10 subnets. How come 10 subnets? Now we have a 5 sites, okay? 1, 2, 3, 4, 5. Each one is connected to the internet. So this is a subnet, and we have the other interface with the internet. It's another subnet, the 1. So 2, 3, 4, 5. So the total number of subnets needed here is 10, not 5. Why 10? For each group, we have a subnet, and for each one interface, we need a subnet. So the question is the following. How many bits we should borrow in order to subnet the original network with a 22 prefix to a number of subnets meeting our requirements? So how many bits we should borrow from the host portion? Actually, we should borrow 4 bits. Why? If we borrow 3 bits, So how many subnets we can create? 2 to the power 3 equal 8. So we did not meet the requirements. We need 10 subnets. So if we borrow 4 bits, 2 to the power 4 equals 16. So we can have our 10 subnets if we subnet our original network 172.16.0.0/22 to 172 now .16.0.0, but what's the prefix will be? At 26. So the new subnet will be 255.255.255.192. Now, how many bits left for the host? 6 bits. It was 10. We borrow 4. So 6 bits now for the host portion. 2 to the power 6 equal 64 minus 2. So 62 host address available per subnet. So we will meet also the maximum requirement of public IPv4 addresses. So in this case, we will use the prefix 26 to create 10 different subnets, and per subnets we have 62 usable host address. واضح? Do you have any question? في أي سؤال؟ في أي سؤال؟ Now, what's the V?
دكتور بعد
نعم.
إذنك تقدر تعيد كيف نحسب السبمت ماسك؟
الآن السبنت ماسك هذا عندي 26.1. ال 26.1 يعني أول أوكت 4 بت 8 ones 255. ثاني أوكت 8 ones 255. الثالث 8 ones 255. الرابع 1 6 zeros for the host portion. الآن ال 1 هذه عبارة عن 128 زائد 64 اللي هي 192. طيب هذه الهوست، هذه الزيرو، هذه الهوست بورشن، معناها كم يوزابل هوست ادرس عندي؟ 2 to the power 6 minus 2 اللي هي 62. طيب ليش minus 2؟ دائما الاول للنتورك والاخير برودكاست ادرس. تمام؟
تمام.
محتاجين نركز فيها هذه. شوفوا الاسم variable length subnet mask. variable length subnet mask. What does that mean? طبعا هذا الفيديو, if you watch this video from the net acad, it will be very clear. Simply, the basic of the VLSM are the following. Subnets do not have to be equal size, as long as their address range do not overlap. Yani we do not have, or we do not need to have equally sized subnets with the same number of host pair subnets. Now, when we create the subnets, keep in your mind, it's easier to work from the larger number to the smaller number. How? For example, suppose we have this network 192.168.10.0/24. From this network, I can create 4 subnets if I borrow 2 bits. So the first subnet 192.168.0.1, the magic number, it's 64. So we'll add 64 here. 192.168.64.1.64.128.192. Now, what's the VLM? VLSM. We'll take the last one. Because of this, we say to start from the larger to the smaller. And we can use the last one to have two more smaller subnets. So from 26, this one will be subnetted to another two subnets, and each one will have 22 hosts, 32 hosts. Why 32 hosts? 2 to the power 5, 34, or sorry, 2 to the power 30 hosts each. 2 to the power 5, 32, minus 2, 30 usable hosts. So we take the largest subnet, we create another two subnets from one subnet. So we will have 192.168.1.192/ what? 27. And then we will add the magic number. The magic number is 32 here. So 32 plus 192, 224. So this is the main concepts of the VLSM. Subnets do not have to be equal size. We started from the larger and moved to the smaller. So in this case, we can create different subnets with different size based on what? Based on the network requirements. So let us have this example. Suppose the original network is this one, 172.16.0.0/23. Now our network requirements are the following. We need one network, and on that network we will have 200 hosts. We need another network, and we need 100 hosts. Another network is needed for 50 hosts. One more network is needed for 25 hosts. One more network is needed for 10 hosts, and 4 point-to-point network, one-to-one, router with a router, for example, and 2 hosts needed for each point-to-point. So my question, how we can cover our network requirement from a single network? The solution, we will use the VLSM, variable length subnet mask. Now, remember, we start from the larger to the smaller. So what we can do, we can simply do the following. We can say 172.16.0.0/23 will be divided into two subnets. Each one will be with a prefix 24. So the first subnet, now as you see, the magic number here is 1 in the oct number 3, in this oct. If we subnet /24 and borrow one more bit, so we'll have two subnets, each one with a prefix 24. So we have 172.16.0.0, 172.16.1.0. Okay. Now what we can say, we can allocate the subnet for the first network. Now we need 200 hosts. This network will have 256 host address. So we're done with the first requirement. Now, what we will do, we will take this and subnet it to another two subnets. So from /24, sorry, we'll have a /25. We'll borrow one bit from this network now, or subnet. So we'll create two. The first one, 172.16.1.0. Now the magic number is the last bit on OCT4. And the second one is 128. So now here we have 128 host address pair subnet. So we can assign this to the second requirement. Done. Now we'll take this and create two more subnets, 64 host pair subnets. So from /25, we have now /26 subnet. The first one will be assigned to this network since we need 50 hosts. And the second one will be, so we'll borrow one more bit. So the prefix is 27, 32 host pair subnet. So I can assign the first one now or allocate it to this network. And we will take the next subnet and create another two subnets. So what we will have, /28 prefix, two subnets. So the first one will be assigned to this network. Now, which one is remaining? 172.16.1.240. Now we will not submit it to /29. Why? Why we decide to submit it to /30? Now, if we take /29, we will not have 4 subnets and 2 host address pair subnets. So we have decided on the last one to submit it to 4 different subnets, 4. So we will borrow 2 bits. So 2 to the power 2 equal 4. So we'll have 4 subnets, and for each subnet we have 4 host address. 2 of them will be for the network and the broadcast, and 2 another host address will be available for the usable host address. So we'll have 4 subnets, each one with 4 total number of hosts, not usable hosts. So we can allocate each one to each point-to-point network. So we'll have 4 point-to-point network in this case. So what we did here, instead of subnet our network to equally size network and waste many available subnets, we can use a variable length subnet masks. And this one, for the VLSM, I will add many exercises on the LMS, and we will discuss it also in our next meetings. So, let us take one more example. Suppose we're having this topology. So on this topology, how many subnets we need? Can you tell me how many subnets? We need 7. Why 7? 1, 2, 3, 4, 5, 6, 7. Now, let us have a look to the network requirement. For the first one, 25 hosts, 20 hosts, 15, 28. So the maximum number of hosts, it's 28. Now, if we use the prefix 27 or /27, how many subnets we will have? /27 means we have borrowed 25, 26, 27, 3 bits. So 2 to the power 3 equal 8. So we'll have 8 subnets. Now, how many usable hosts per subnet? 2 to the power 5. 2 to the power 5, 32, minus 2, 30 hosts. So if we use the prefix 27, we can have 8 subnets, and each subnet will has 30 usable host address. So in this case, we will use the first subnet for building A, the second one for building B, next one for building C, building D, and subnet number 5 for these 2 hosts only. So how many hosts we have used here? Only 2. And how many hosts we have wasted? 28 unused host address. Same concept here, 28 unused host address, 28 unused host address. Also, we have 1 subnet, it's not used at all. 192.168.20.224. This is the subnet number 8. Now, my question, is this a professional subnetting based on the network requirement? No. No. Why? Simply because of the following. Now I have a 3.2.1, and each point to points requires only 2 addresses. So we have already wasted 28 addresses for each subnet. So the total number is 84 unused addresses. How come 84? 26 unused address here, another 28 here, and another 28 here. So applying the traditional subnetting scheme in this scenario is not very efficient. So what we can do? Simply, we will use the VLSM, variable length subnet mask, for the last 3 required subnets. So what we can do, this is the original subnetting, okay? We can take the last subnet, the unused one, and we will subnet it from /27 to /30. In this case, we will have 8 subnets, and we can assign 2 hosts per subnet. So we can use the prefix 30 for the 2 hosts, and we can keep the 27 prefix for the larger network. So the left side in this diagram display the traditional subnetting scheme, equally sized subnets, while the right side illustrate how the variable length subnets can be used. We take one of the subnets and we subnet it by using the prefix 30. So we have 1, 2, 3, 4, 5, 6, 7, 8 subnets, 2 usable hosts per subnet. So it can be used to submit a subnet and divided the last subnet into 8 prefix 30 subnets. So when using the variable length subnet mask, always being by satisfying the host requirement of the largest subnet and continue subnetting until the host requirement of the smaller subnet are satisfied. So when we're using the VLSM, always start from the network that having the maximum number, the largest number of hosts, and move forward until you reach the smallest one, from the larger to the smallest. So we start with 28 and 25, 20 host 15. Then we handle the 2 hosts per subnet. So in this case, in case we need to extend our subnets, we have many unused subnets with 30 hosts each. Also, we have 5 unused subnets with the prefix 30. We have used only 1, 2, 3 subnets with a prefix 30 out of 8. So we have 5 unused also subnets. So by using the variable length subnet mask, subnets, the LAN and the inter-router network can be addressed without unnecessarily waste unused IPs. Only 2 hosts, 2 hosts, 2 hosts, and we have met the requirement each one, 28, 15, 20, 25. So we have used /27 and /30 on the same network. This is the main concept of the variable length subnet mask. أي سؤال؟
والله يا دكتور نحتاج أمثلة كثير صراحة، أنا ضعت منك.
لا أنا ما بدي تضيع معي، أنا بدي نفهم الكونسبت. الآن VLSM السبنت اللي بالنتورك مش نفس البريفكس، مش كلها 27. الآن بالمثال هذا خليني أشرحه بالعربي مرة ثانية. عندي أكبر عدد من الهوست مطلوب عندي 28 هوست، كويس؟ وأقل واحد 2. الآن كم سبنت محتاج أنا؟ 7. الآن لو استخدمنا التراديشنال سبنت، التراديشنال سبنت قلت لك راح نستعير من /24 3 بت، يعني 25 26 27، معناها صارت /27. استعرنا 3 بت، معناها عندي 5 بت افيلبل للهوست ادرس لكل سبنت. 2 to the power 5 minus 2، معناها كم يوزابل هوست ادرس عندي؟ 30 يوزابل هوست ادرس. كم سبنت عندي لما استعير 3 بت؟ 8. تمام؟ جيت خليت هذه /27 وهذه 27 وهذه 27 وهذه 27 وهذه وهذه وهذه. الآن باقي عندي سبنت ما استخدمتها، هذه باك اب. ممتاز. الآن سؤالي، كم هوست هنا محتاج بين الراوتر والراوتر هذا؟ 1 هوست 1 هوست 2. كم ادرس محتاج بين راوتر 2 و 3؟ 2. كم ادرس محتاج بين 3 و 4؟ 2 ادرس. طيب الآن لو خليت هذا /27 عندي 30 ادرس، استخدمت أنا فقط 2، معناها كم ادرس بذرت؟ ويست unused
28.
ممتاز. وهنا كم واحد؟ 28. وهنا 28. الآن الكلام هذا غلط. طيب الحل VLSM VLSM. VLSM ايش عملت؟ قال لك اخر سبنت من ال 27 اخر سبنت هي هذه، خلينا نرجع نسويها سبنت منها، يعني هذه السبنت نساوي سبنت منها. فمن ال 27 احنا كم هوست محتاجين لكل سبنت؟ 2. معناها لو تركت 2 بت فقط، اخر 2 بت للهوست 2 to the power 2 minus 2، ما تنسى minus 2 معناها 2 usable host address. ممتاز. معناها السلاش 27 ممكن اقسمها انا لسبنتس اصغر منها هذه باستخدام البريفكس 30. فراح استعير البت 28 و29 و30. كم بت استعرت؟ 3. كم سبنت عندي؟ 2 to the power 3 8. معناها سويت 8 سبنت من هذه، من السنجل سبنت. كل سبنت من ال8 هذه ممكن اعطيها 2 usable host address. فعندي تبذير الان ولا ما عندي؟ مين الافضل؟ نخليهن 27 ولا لا نرجع نقسم لاصغر؟
نعم.
مين
صح.
الافضل؟
افضل تقسيم.
هذا مبدا الفاريبل لينك سبنت ماسك، هذا الكونسبت تاعه. وضحت؟
نعم.
الان دونت وري، راح ان شاء الله نيكست ساندي راح نشرح الاكسرسايز. الاكسرسايز الاول، الساندي اللي بعده نشرح الاكسرسايز الثاني، نتاكد انه اموركم فيها طيبه. تمام؟
نعم. نعم. الله يرضى عليك. شكرا.
طيب ممتاز. طيب الان finally هنا some guidelines. Any network administrator should put a plan for IPv4 network address planning. يعني ما تقسم راندوملي عشوائي، شوف الريكوايرمنتس وبناء على الريكوايرمنت قسم. So IP network planning is very important, crucial to develop a scalable solution to an enterprise network. الآن ايش scalable هنا؟ I can extend my network. الآن بالسيناريو هذا عندي الآن 3 subnets with prefix 27 unused، لأن استخدمت 1 2 3 4 5 6 7 مش مستخدمات، وعندي 5 subnets with the prefix 30 unused. فماي network is scalable in this case. ممكن تتوسع بمعنى آخر. So to develop an IPv4 network wide address single scheme, you need to know, now before you submit any network, you need to know how many subnets are needed and how many hosts a particular subnet requires. Also, what devices are a part of the subnets. So which part of your network use a private addresses and which part will use a public addresses, and many other determining factors. So we need to know how many subnets, how many host pair subnets, which network using a private address, which network with a public addresses, even which or what's the device part from that subnet. Why? All of these requirements will help you to have a good planned structure to your network. So examine the needs of an organization, network usage, and how the subnet will be structured. Check the requirements. After that, you can decide how to subnet your network. So perform a network requirement study by looking at the entire network to determining how each area will be segmented. Determine how many subnets are needed and how many hosts per subnet. Remember دائما اليوزابل host 2 to the power n. الان اللي هي البيت for the host portion minus 2. الان اتفقنا من last class اول address it's the network address. The last address is what? The broadcast address. ما تنسوا. الان between اللي هي اليوزابل host addresses. So within any network now, or within a network, we have a different type of devices that require addresses. So what we have here, the type of the devices and the address type for each of these devices. For example, for sure we will have end user clients. And mostly end user clients, most network use the DHCP, Dynamic Host Configuration Protocol, to reduce the errors and build on the network support stuff, reduce the requirement, the maintenance of the network. Now, what's the type of the address will be used here? Private IPv4 addresses, network clients, end users. So most network here allocate IPv4 addresses to the client devices dynamically. How we can allocate a dynamic IPv4 address to any end device here by using the Dynamic Host Configuration Protocol in order to reduce the errors and eliminate the errors. Now, IPv6 client can obtain an address information by using either Dynamic Host Configuration Protocol version 6 or SLAAC, Stateless Address Auto Configuration. In a network, we will have also servers. And these servers or the peripherals require access from the internet. So for sure, what's the IP address will be a static IP address. It will be a public IP address. So we can configure these type of devices with a public static IPv4 address to be accessed through the internet network. And usually we are using a NAT to access these devices, network address translator. No, also we will have some servers in the network that are accessible from the internet. Server must have a public IPv4 address, usually using the NAT. Sorry, the peripheral service that should be predictable, static IPv4 address or IP address. Use a consistent numbering system for these devices. Usually, when we talk about the servers, the printers, they will have the same static IP address. Intermediary devices are assigned address for the network manager, monitoring and security. And they should have predictable also a static IP address, gateway or the router gateway, and the firewall device are the gateway for the host in the network. Usually the first usable IP address will be the gateway address actually. So when developing an IP address scheme, it's in general recommended that you have a set of pattern of how addresses are allocated to each type of the device. So we have a different devices with different IP address types. Now this is the end of module 11. Now what I have or what I will do, لحظة بس.